Hello, welcome to Generation AI, the podcast where we demystify artificial intelligence in the world of higher education. I'm your host, Ardis, Kadiu, and today I'm joined by special co-host, much smarter and maybe 10 years younger version of me, Petar Djordjevic. Hey, Petar, how's it going?
Hey, Ardis. Thank you for having me. And I don't agree that I'm smarter, but I am younger. I am younger. That's true.
Well, I'm envious nonetheless. Like, you're also a much better traveler than I am. Where are you today?
I am in Lao and in Luang Prabang. Far away. Far away.
For those of you who don't know Petar, he is a avid traveler. How many countries have you been to so far?
This is our 48. So me and my wife are trying to see the whole world. So basically doing like one country at a time. So 48 so far. It's around 25% of the world. We still have a lot to go.
Man, I'm so jealous. So by the time you're at my age, you've seen all the countries.
At least 100. That's the plan. At least.
That's great. That's great. Well, today we're going to talk about a special topic, but kind of a little bit more of a frontier topic as well. So we'll talk about agentic systems or agentic AI system or agent-based AI systems. We can call them proactive systems. You know, AI can do just a lot more than being a co-pilot and basically being reactive. So it can act on its own and it can within guardrails, and we'll kind of decompose a little bit about how these systems work and why we think this is like the future. Petar, by the way, he's the, we didn't do a proper introduction here, but Petar is the CTO at Element 451, and he's been kind of leading the charge on a lot of the AI development that we're doing here at Element and the actual implementation of that. What have we built so far? Like where do you think we are so far in terms of AI capabilities?
So I'll start kind of like just to give a little bit of context of how we actually started as well, and then kind of like go through to that point. So initially, as all people who kind of like are following right now know that when GPT-4 got released, it kind of like opened a whole new world for a lot of companies. Some problems that were hard to solve before are now becoming a little bit easier. And the whole point is that kind of like with GPT-4, we have seen that this level of AI is able to reason up to a certain degree. That reasoning is still not to a human level. We are far from there, and there's multiple reasons from like how it's internally built to these types of models are not the kind of like the ones that will actually replace people at all. But basically, what GPT-4 gave us as capabilities is understanding text, right? And fitting text is kind of like a non-structured type of data. And that's been a really hard problem that people were trying to solve for a long time, because you can't code programs on top of non-structured data. Right? You need to give it some meaning, some structure. So GPT-4 gave us that ability. It gave us that you can take any text and potentially understand it and maybe output some data, like a certain data format that you can then code on top of that. So you can see that how we thought of it with Element is, of course, we were not like machine learning experts when we started building AI. We saw it as a tool. Hey, can we use it to build certain things to make our customers' lives easier? And opportunities initially were like low-hanging fruit, and you can see that in a lot of products. Hey, can you just do like a quick translations, or can you help write better? Can you summarize long conversations, right? But then things started expanding, and you saw this is where kind of like the agents were starting to come into play. You saw that with the first chatbots built with GPT-4. You probably sometimes might have been confused if you read a lot of blog posts. People immediately started talking, hey, agents, why agents? So it's kind of like a little bit overloaded word, because people didn't want to say, hey, these are thinking people, because they're not at that level. But this is not just code running, so it's something in between. So the agent was kind of like a good code word for that. But the first example is you probably used it already, is a chatbot. A chatbot is an agent because it cannot just do like, hey, Q&A. It can actually reason and handle the conversation in a certain and different pathways. It's not always just how you tell it to behave. It's a little bit more open-ended. So first agents were actually the chatbots, and Element, for example, has implemented a couple of them, both on the student side and also on the staff side. So our journey has been kind of like really, we covered a lot of different aspects. And eventually what we eventually also built kind of like as our fourth big AI product was our Bold Discovery that we just announced a couple of months ago, which kind of like is like a search engine, similarly, but built using AI. So yeah.
Let's take this a little bit broader, right? Like let's think about this a little bit broader. So where we are today from an industry or from AI capabilities, right? we had not seen anything that was taking a specific task or a particular outcome or a workflow and converting that into a fully built out output until recently when we posted on this podcast when we talked about Devin, which was an AI coding agent assistant. And essentially, the idea was, I'm not going to tell you everything that you need to do step by step, or I'm not going to give you this prompts, but I'm going to give you a goal, and then you're going to figure out how to get the output of that particular goal. So as we start thinking about the world today, and we talk about AI agents, I believe we're in that beginning phase where we're now moving towards proactive agents where they're advanced systems and they not only respond to our commands, but also anticipate needs and take actions autonomously, right? This idea of autonomous actions based on goals is very, very important when we think about these AI agents.
True. So if you're thinking about that, chatbots, right, as kind of like the first agents were more reactive, right? They were only handling something on a certain input that was coming, but kind of like where the industry is evolving, but slowly because people are still trying to figure out this problem is, can this AI run constantly on its own and basically decide what to do based on, as you said, kind of like a high level task? Hey, this is your job, this is your role, these are your tools that you have. Can you accomplish this for me? And then kind of like help the company succeed. And you can actually see that, I think it was Sam Altman that said, right, that he thinks that better, we might even see like a $1 billion company, right, with a single employee, basically, because a lot of the work could potentially be automated, and you can use AI kind of like as your staff as well. I don't believe that yet. It's not at that level, and I think we are far away. But I do see AI as a big help for every employee currently, right? I don't see it as a risk for replacing jobs. I more see it as a kind of like a power up. Like every employee will have its own staff member that they can use, its own team member. Basically, every employee becomes a manager. So they start to think now strategically. Hey, instead of how you do it, you can just say, hey, can you do this for me while I think what the company needs next? So that opens a lot of possibility.
So you're thinking the idea is that the goal orientation here, like having a goal, is the most important thing.
Right. Think of it as a company. How do we do our own company, right? We do have like our yearly goals. What do we want to accomplish? What's our vision, right? And then you need to communicate that to the rest of the organization and kind of like align everybody to be able to do that. So it's similar to this. We don't know when the year starts how we will get to the end of the year, right? But we know, hey, this is where we want to be.
We're not there yet, though.
We are not there yet.
We're not there yet. Yeah. Now, what makes something, proactive?
So it's, again, if I give a comparison to a company, right? Which employee you like the most, right? Which helps you the most?
Well, you, of course. I mean, that's, I like you the most.
But who makes your life easier, right? Generally, with characteristics, like somebody who's proactive, right? Somebody who will go in and try to detect what job needs to be done based on the current situation that it sees, right? Because there's no way a person, like, for example, you as a CEO, you cannot see all the problems and solve them yourself. It just doesn't scale, right? You need to hire people that are better than you at these types of jobs and do it. So let's apply that to this mini world, right? This is mini world. Let's apply it to and say, hey, can these agents actually solve a certain problem using that approach? So if you think in our world, right, we are trying to solve the problem of student engagement, right? For example, one of the cases in student engagement is handling applicants or potentially prospects and kind of helping them apply and getting them to actually come to your school. So there can be a lot of them, right? And there's a lot of data points that you might collect, that you might get, that you all the conversations that you had with them, also kind of like your input that you have from your team members and staff members that are evaluating the student as well. Can you imagine run a process in the background that takes all that input? And that input might not be structured, right? There's text and there's also structured data, but there's also just text, your own opinions. Taking all that and creating a new opinion based on which you can do something. Either it itself can do, or it can just tell you, hey, I'm planning to do this. Would you allow me to do it? That's how I envision proactive assistance. Just because right now, if you think, hey, there was a big movement, big data, right, in the last 10 years, like we were collecting a lot of data, we were storing all this data, we need to hire a lot of people to analyze this, to give us what to do. What if AI can do that? What if AI can be the one pulling in all that context of a person, knowing where they are currently, what's their current situation, and then trying to help them move towards certain goal or kind of like traverse a certain journey, right? And if you think about this, it's similarly how we solve current chatbots, right? You ask a question, AI goes in, tries to find relevant information, uses relevant information to answer that question. What if in this case, there's no question, there's a problem, and it has access to certain data to solve that type of problem? Like the framework is already there. We have been using this. But now it's just approach. How do you run this? How do you scale this type of approach? Where do you put it? How do you put guardrails? So there's a lot of things to kind of like figure out how to run this in production.
Interesting. So when we're thinking about proactive, like let's just take a very, very simple example, right? So if we take like let's say like a virtual assistant, right? You tell that virtual assistant, you answer questions, you ask questions, check my email, what are my top, what do I have to do today? Like those are the things that virtual assistant can do for you, but it's all driven by you, right? It's all action driven by you. Whereas if we have a proactive AI agent, it kind of analyzes certain patterns. It can predict kind of future requirements and then initiate actions independently. So for instance, this proactive AI assistant might schedule a meeting or send reminders or adjust, even adjust your environment based on things that he has learned in the past or depending on goals without a user prompting them to do something. We're actually seeing a little bit more of these predictive, you can call them predictive systems, like with smart homes, for example, that they learn your patterns and they kind of adjust. They can be considered proactive assistants or proactive agents as well. But now imagine having these agents on every part of your life and actually do knowledge work, right? They can sit in the background and then based on certain goals, they can kind of anticipate what they need to do and listen for things. And based on their job or their requirements, they can then kind of spring into action and do certain things, right?
I think the Devin is a good example of one thing is writing code has potential security implications, and it can open up problems, right? And then you can get hacked if code is not optimized. So with Devin, you can see an approach that the industry kind of like has chosen, and that particularly shows that hey, you will never replace people, right? You always need people to run AI. And in this case, is with Devin needs to talk to a person. So even though you will give a Devin a job, Devin will do something, you'll ask for feedback, and you will refine it until you get to the completed program. But basically, you are guiding it step by step. So you have total control of what's going on, and you have in every step of the way, you can see all the output.
You can interrupt it. Is that what you're saying?
You can interrupt it. Yes, you can interrupt it. You can even change its state. You can say, hey, I don't like this, delete this, and then you can start over or go even back as well. So that's an important step. Industry starting to call that. You probably heard a lot like human in the loop. This is a little bit different.
Human on the loop.
On the loop, right? You human observing, maybe even letting AI to run and deciding when to interrupt. So that's different. Devin right now is even more reactive than proactive because you will give it a job, it will start to do something, but until you say, hey, you need to continually progress until you get to the completed job. And that will improve. As AI gets better, you will get better models, and eventually they will maybe understand us even with like one sentence what they need to do, which sounds impossible right now. But who knows how that will progress. Right now you need to, because that's the state of the technology. But there are simpler problems. Coding is a complex problem because it's so open-ended and you can approach it in different ways, but there's simpler problems that you can do. For example, hey, I want to re-engage a person that has been our customer and stopped communicating with us. That's a much simpler problem to do, right? Can you analyze like their patterns? How did they communicate with us? What did they like? What they didn't like? And can we use that in a way to reach out and potentially spark new interest, right? So that type of problem is much lower in terms of risk. There's not a lot of security implications. And imagine if you have a human on the loop, kind of observing, is the kind of the process going good, potentially interrupting if they see that the kind of the message being sent out is not personalized well enough. So that's kind of like the type of agents we want to talk today, as how do we transition from the reactive to the proactive approach.
So when we look at these agents, right? So we talked about what makes these possible, and this frontier large language models, which is the brains, and it gives us some reasoning capabilities. So these frontier models allow us to do a lot of these complex things. And, we're not just seeing it with text. Now we're actually moving into multimodal with voice as well. So as agents, we need to kind of persist this memory somewhere, right? It's not a one-shot thing. It's like you need to do something over multiple steps, and you need to remember what you did before so you can understand. So how do we think about like this ability for them to remember things?
Hey there, it's Mallory, Chief Strategist of Enrollify. Higher ed is facing a leadership crisis. The demands on today's college and university leaders are skyrocketing, and talent is leaving the industry at an unprecedented rate. New leaders like you are emerging, but no one is getting the proper training to be successful. Well, Enrollify is here to change that. Our new course, Lessons in Leadership, taught by Dr. Carrie Phillips, will prepare you to be a confident, empathetic, and effective leader. From systems thinking to adaptive leadership, building culture to handling difficult decisions, this comprehensive online course is perfect for new and aspiring leaders. Don't wait. The course starts September 9th, and for a lucky group of 26 students, we have the option to add interactive sessions with Dr. Phillips for personalized guidance. Visit enrollify.org to learn more.
Well, they're not effectively remembering, right? It's kind of the system that you build around them that could give them that capability, right? That's a feature, and you saw that potentially in if for people who use ChatGPT, they saw when ChatGPT announced a memory functionality where every time you were writing something, if the fact was really interesting, ChatGPT will say, "Hey, this was saved as a memory," and we'll just save it as text somewhere, and kind of like whenever you're talking to it, it will ingest it to ChatGPT as it talks to you, so it can personalize the conversation. So in theory, if you think about it, that's not a hard problem. Right, it's just like, hey, saving some piece of information and loading it at the right time. So the same thing can be done using potentially mistakes or approaches it took to learn from them. Hey, this is what worked well in a certain situation or what did not work well. And what's really interesting, if you were to have this feature in the system, it opens up two things, right? Either AI can learn on its own, right? But again, it's dangerous if you're not overseeing what's learning. But second, it gives you as a human and kind of like a subject matter expert, potentially a way to give those kind of like, we call them playbooks, and kind of like give those how to behave and what works well in certain situations. So you can kind of like, if you are really good at what you're doing and you're doing a much better job than AI, right? You can kind of like try to teach it, but not doing like all what machine learning experts are doing right now, like training specific models on specific tasks, but basically you just explaining it. Hey, this is what I did. This is what worked. And you're just writing it in text. And that's shown that it can improve performance a lot.
So examples are really good.
Examples, yes. And that can either be inputted by you as a subject matter expert, or you can build a system where AI would do that on its own. Try to detect what it did, what worked, what did not work, and then use it.
So let's stick with the analogy of the stack, right? So you have the brain, which is or the CPU or whatever, which is the large language model. And then it needs to work on stuff, right? And that's the memory, that's the context.
Yes.
So you give it this context. And now if you think about it, it's like, well, how do I remember all of these things? How do I remember all these examples that you're giving me, all of this material that you're giving me? How do I remember the steps that can be hundreds or thousands sometimes of steps? So it's like what we have today is this notion of kind of, if we want to do a task, think about it like at least the way that I think about it is like the computer memory, right? And you think about the CPUs. If you have memory that's very, very close, very fast, and to compute a particular job, but then you need to swap memory back out. So you save this memory, like more memory, like on the side, right? Because you can't fit, let's say, hundreds or thousands of books or thousands of videos or whatever into one place. So you're putting it on the side. Now, I see context as being one of the most important aspects of these large language models when we think about reasoning and doing multi-step, reasoning and tasks. And that could be the difference between, our brain being able to process and understand what the history was versus now having to swap things in and out and having something else that we're making decisions on what memory to give it. And if it doesn't have all the memory, it might not give you the best option. So if we go back to your analogy of an organization, it's like, well, person A, they're in marketing and they don't have the context of the product features that were just released. So now they need to produce something for the marketing, but they don't have that context because they have a very different context. So they're not going to be able to produce the best, marketing material or even produce marketing material that kind of fits in, or even reason about, what do we produce or how do we communicate to a customer that these features were released. So we take that into kind of these agents or proactive agents, and you can totally see that context is the big deal, right? It's a huge deal.
It is. That is. But there are techniques to that already. It's retrieval. It's a hard problem. It's not solved yet, but it's basically getting the right data at the right time. And that's the problem that everybody's trying to solve right now. Every chatbot that you see right now working across the industry that's powered by an LLM, it'll have a retrieval component into it. And the better retrieval you have, the better results you will have. So that's how companies are competing right now. Who has better data and who's able to get that data at the right time, at the right place. And every time you get the chatbot not answering properly, that's probably because the retrieval was not working properly.
So if we look at that, the recall, right? That's the recall of this information. Do you feel that as these context windows for models get longer and longer, we're going to have better and better reasoning? So Gemini, for example, you can fit 1 million tokens context window. It's even gone to up to 2 million. There is some techniques right now that people are looking for infinite, context windows. So if we're asking these agents to think of a step, like thousands of steps, like this idea of a chain of thought, right? Maybe you can explain like what chain of thought is. You might have a more simple explanation of that.
Yeah. So for people following, chain of thought is you tell LLM before solving a problem to decompose it into like steps how it will solve it. So same as you, hey, how will I, move this? If you have like a glass and you want to put it somewhere, hey, I need to first open the door of the cabinet and put the glass, and etc. So it's kind of decomposing the tasks. And why chain of thought is kind of like constantly being mentioned. It's not that we think it works. It's because it's been proven. There's a lot of researchers actually trying different methods to see what improves the performance of LLMs on a certain kind of benchmarks. So they're measuring to see what works best. And one of the techniques is chain of thought. And the other techniques that we probably mentioned so far is something called a few shot, which is basically giving examples, as Ardis mentioned. So there's different techniques. You can actually combine them to work to solve their problem, but there's many more as well.
If these models get really smart, right there, and they are really smart, doing chain of thought, it becomes interesting because then they can start thinking in more complex problems. So chain of thought becomes interesting. So then context window, it's like, hey, I need a place to understand where all these things come in. And I mean, we see it for ourselves sometimes when a conversation goes really, really long for us, right? Really, really long. For example, when we start generating a campaign that's, dozens of communications long for Element, you see that like the context window becomes a barrier here because you have to stuff everything in there.
True. So there's different schools of thought that will like larger context allow for better reasoning. So far, it's not been proven. But what it kind of like so far promises, it makes the job of somebody building a system a little bit easier because instead of you trying to solve the retrieval problem, you can potentially stuff your whole data in a single call. But if you think about it, it's the same physics problem, right? Hey, you have a lot of data, right? Having the data uploaded somewhere, you need to, that takes more time, right? And then that thing processing more data also will take more time. So for certain jobs, definitely will make sense. Certain jobs will be made easier. Jobs that can run in the background, jobs that don't need immediate kind of like feedback to give immediate feedback to the user. There will be certain problems where long context will really help, and then probably allow rapid iterations. You can just stuff things in. However, this also allows a potential problem because making something easy also will make certain people be a little bit more lazy, right? So they'll just put things in And as always, as people say, hey, garbage in, garbage out, LLMs can get easily distracted. So that's one of the things that you probably saw already. And if you give it a lot of unnecessary information, it might choose that information is relevant for some reason and go in a certain way that you didn't want to. So you always need to be thoughtful. And I don't yes, it's good to expand the context size, but I don't think it's necessary. I think retrieval will be good enough for a lot of the use cases that we have right now. We'll see. Maybe I'm wrong. I'm not an expert. So FYI. So
we brought you here as the expert. You're a practitioner, right? You're a practitioner and an expert.
Practitioner.
You're reading the papers. You're most of an expert than 99.99% of the folks who are doing AI right now. So I would not say that you're not an expert. When we start thinking then these complex tasks, right? So right now we're working with just one agent. We're working with just one system, and they're really good at doing something. But then this proactive AI assistants, we can think about them what happens when we do complex task management? How do we handle multi-step tasks, and how do you coordinate that? Are we going to have a place where we now have just one agent do everything, or
how would you do it? How would you do it right now in real life?
Yeah, I mean, so this idea of having an AI agent, a proactive agent for very specific things, and as I've done a lot of this research, or as we've done a lot of this research, there is a lot of folks out there who are building AI agents for wearables, for example, or for systems that are passive, right? That they're basically in the background and helping you out. And one of the examples of an AI agent was this notion of, hey, you have a health agent, or you have an eating proactive agent, an agent that his job or the goal is to be as helpful as possible to tell you about food and your calorie intake. So one of the examples that came to mind is that if you're wearing glasses, and let's say that you have that agent running in the background, of course, that's one of multiple agents, right? But it's proactive. So that agent's idea is okay, I'm getting all this input, all these images, I'm constantly processing it. My job is to pick out items of food so I can comment and be helpful around food, right? So let's say then you open the fridge door, it looks at all the stuff, you pick up an apple, it tells you, oh, that's a great choice, it's healthy for you, here's how many calories it has, and it shows that up to you, right? It bubbles up that information to you. Now imagine you have 10 or 20 or 100 AI agents. One of them is for the temperature, telling you the weather, if you should bring an umbrella or not. One of them is for, let's say, your blood pressure. One of them is for, the mood you're in. One of them is for your calendar that comes, from your work, work assistant. One of them is your kid assistant. So you have all these proactive agents that have different jobs, and you have dozens of them or hundreds of them. But not every one of them needs to be bubble up or tell you everything all at once, because they're constantly telling you stuff, right? They're constantly working, and they're like, oh, this apple will be really good for your kid. You should probably just give it to him, and they'll really appreciate apples, and they should eat their vegetables, and so on and so forth. But they're nowhere around, so why would I need to know that information, right? So this notion of how do they work together, or systems, becomes really, really important. So not only do we have agents or proactive agents, but then how do they collaborate together and know exactly when to take the information of each one? And with the wearables, it was really interesting because some of these systems that are getting built with wearables, it's exactly that. It's it's not going to display to me that, let's say that I just had lunch, right? And then I passed by an ice cream shop or a food truck or whatever, and it's not going to tell me that the calories on this food is this much, right? Because, of course, it's going to calculate that in the background, but it knows that I just ate lunch and I don't care about any more food right now. So it suppresses that particular output. I thought that was very, very interesting. And as we start thinking about these proactive agents, that we're going to have a lot of them. So how do they work together to get to a goal or an outcome as they sit in the background? What are your thoughts?
Well, I find this really funny because I will again go to the same example of how do we organize companies, because it's the same problem. You have a lot of problems being solved at the same time, right? In parallel, not everything needs to be bubbled up, right? Something stays in the department, something goes a little bit higher, because it's the same problem of organization, especially if you have like experts focusing on one thing, which we have in this thing, right? But because it has been proven that the general AI is not performant, but specialized AI is really, really performant. So in this case, if you think about it, you would need some type of coordinator, right? Some type of manager is the actual one who actually decides what to display to you and tracks the current state. Hey, this is what happened. I'm getting all these inputs, and I can bubble up what's relevant. So to kind of like, he's kind of like the gatekeeper deciding what to do. This is just one of the potential approaches, right? But if you think the inspiration of how to organize them comes from the real life, and probably we as humans, we will find patterns in what we do, so we'll kind of try to apply them in software as well. But it's actually been proven really well that you can solve complex problems in AI using organizational structures of people. And then we have actually an example in Element. One of the problems that we needed to solve was to kind of build a full campaign for a school, for a certain topic, for a certain problem. And if you think when it comes to building a full marketing campaign, it's not a single person building it. There's multiple people being involved, from people they need to pick what type of media will be used in terms of photography or video, or there's person who need to write, there's person who need to design. So they all need to kind of like work together to get to the same goal, and somebody needs to orchestrate that. And we actually that's actually what we decided, and that's what actually we have implemented. And it turned out to work really, really well. Because now when you have these little kind of like special areas that kind of like are isolated, they can focus on just getting their job to be really good. So a writer that needs to write really, really well, and kind of like its main job is to personalize. You have a lot of control, and especially as the systems get more complex, you get more of these. It's easier for you to reason when you can isolate down to a specific little module, right? And in this case of wearable, right, you need to build a really good detection system for detecting fruit and outputting calories, right? That's the problem that you need to solve. You don't need to solve everything, so you can solve that, and then you solve something else and something else, and all these things kind of like add up. So organizational structures for people tend to map really well to solving complex problems with AI as well.
Well, I think this is a really good kind of check-in point. Petar, thanks so much. We're going to continue our conversation and start discussing like the practicality of these proactive agents in higher education and how we're thinking about these and go into a little bit more detail about, exactly what they mean. We're going to talk a little bit more about things like the future outlook of these, like the behavior and ethical dimensions a little bit as well, that human on the loop, and what are some of the problems that we're trying to solve. We'll save that for the next episode or the second part of this conversation. But until next time, thanks everybody. Talk to you soon.
Thanks everyone.
Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.